Welcome to aminacademy.com. In fluid mechanics, let us discuss about velocity of approach. Velocity of approach is defined as the velocity with which the water approaches or reaches the weir or notch before it flows over it. Here, the velocity of approach, then an additional head of HA that is equal to VA square by 2G. Velocity of approach equal VA. Then VA we can write in terms of head, that is then HA equal VA squared by 2G. We converted in HA. Now when velocity of approach, that means it acting on the water flows over the notch. The initial height of water over the notch becomes H plus HA. Already initial height is H, then the new initial height become H plus HA. You can put it small HA. Now the velocity of approach VA is determined by finding the discharge over the notch or weir, neglecting velocity of approach, then dividing the discharge by the cross-sectional area of the channel on the upstream side of the weir or notch. The velocity of approach is obtained mathematically. VA, velocity of approach, Q, discharge over a notch, then area of channel. This velocity of approach is used to find an additional head of HA VA square by 2G. Again, the discharge is calculated and the above process is repeated for more accurate discharges. Again, the discharge is calculated by above process, that is, therefore actual discharge with using velocity of approach also we have 2 over 3 Q equal 2 over 3 CD, that is coefficient of discharge, length of channel, and root of 2G into H, that is you can put it velocity of approach is with velocity approach H1 plus HA power 3 by 2 minus HA power 3 by 2. This formula you have to use it to find the actual discharge with considering velocity of approach also. Now let us do one example problem regarding this concept. Water is flowing in a rectangular channel of 1.2 meter wide and 0.8 meter deep. Find the discharge over the rectangular weir of cross crest length 60 centimeter if the head of water over the crest of weir is 25 centimeter and water from the channel flows over the weir. Take CD, coefficient of discharge equal 0.62. Neglect end contraction. Take velocity of approach into consideration. Now we'll find the area of the channel, width and length, that is 1.2, 0.8, which is equal 0.96 meter square. Now H1 height of water above the crest is 25 centimeter, that is 0.25 meter. CD 0.62. Now let us find the discharge over rectangular wire without velocity approach. First, without considering velocity approach, velocity of approach, that gives the formula Q equal 2 over 3 CD L 2G into H1 3 by 2, which is equal 2 by 3 0.62, L is 0.6 because 60 centimeter become 0.6 meter into 2 into 9.81 into H1. The H1 is 0.5 power 3 by 2, which gives is 0.1373 meter cube per second. Now velocity of approach. First, velocity of approach VA equal that Q by A 0.1373 over by 0.96, which gives velocity of approach is 0.0104 meter per second. That now we'll convert this velocity approach in terms of head, that is HA equal VA squared by 2G, that is 0.0104 the square over this one Q by A, that 0.1373 over 0.96 equals 0.143 meter per second. Then V squared by VA is 0.143, that is square over 2 into 9.81, which is equal 0.00104 meter. Now we'll find Q by using discharge with velocity approach. Now discharge with considering velocity approach. That is equal Q is 2 over 3. Q is 2 over 3 CD L into 2G into H1 plus HA power 3 by 2 minus HA power 3 by 2. So we'll use the calculation, that is 2 over 3, CD 0.62 into length is 0.6, 2 into 9.81, H1 plus A, that is 0.25 plus 0.00104, that is 3 by 2, minus 0.00104 power 3 by 2. Now which is equal, here this up to this calculation we have 1.09985 into this, that is 0.25 plus 0.00104 whole power 3 by 2 minus 0.00104 power 3 by 2, which gives 0.125747, 125747 equal 0.138133 meter cube per second, which is equal 138.13 liters per second. Here, look at this. Without velocity approach, the Q is 0.1373 meter cube per second. With velocity approach, 0.138133 meter cube per second. Little increase in discharge because of its velocity approach considered. We have done. Please subscribe our YouTube channel.